As you said, I mean, a lot of these assets, they were not built to be easily accessible because of the things that we can climb and scale. It enables us to do that without ever taking things offline.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about finding better ways to make the most of our critical fleet of power plants. One of the reasons I started this podcast was to shine a positive light on these facilities. Nuclear, natural gas, coal, we need them. They're the backbone of the system and the reliable power needed when wind doesn't blow and sun doesn't shine. Inevitably, they go down. Most of the time, this is during routine planned outages. In nuclear's case, you have to take the plant down to refuel. In other cases, operators need to perform routine inspections. In most cases, these inspections are mandated in order for the plants to continue to operate. I've been on site for maintenance like this, like boilers, where you open it up and look inside. These inspections require a human, usually crawling into a confined space or dangling from a rope to painstakingly inspect for cracks, wear, and potential failures. My guest says this is inefficient, and yet it remains the status quo to this day. He didn't come up with a solution his company now uses. To hear him say it, it came from a power plant operator who thought there could be a better way. The solution my guest would go on to develop will remind you a lot of your friendly neighborhood, you know.
Spider-Man, Spider-Man, does whatever a spider can. Spins a web any size, catches thieves just like flies. Look out, here comes the Spider-Man. Is he strong? Listen.
It actually looks like a spider, in fact. They developed a number of robots that can cling to the sides of boilers, tanks, pipes, you name it. Armed with several sensors, they can take thousands of measurements simultaneously, where a human would have to do so singly and much less thoroughly, they argue. I also pointed out during the interview that using a robot could mean getting out of permits since you wouldn't be endangering a person's life. With better data, my guest says they don't have to take the plants down as long or sometimes as frequently. And yet, many facilities still do it the old way. As cool as this technology is, engineers are rarely swayed how cool something looks on Twitter. But my guest says the results they've achieved have helped make a name across the industry and are quickly making this Wondrous Wallcrawler an industry standard. My guest today is Troy Demmer, co-founder and COO of Gecko Robotics, an industrial automation company based in Pittsburgh. I first learned about Gecko during my interview with the Dry Scrubber Users Association earlier this year. I remember saying to those guys, who are they? Though the sight of robots climbing impossible shapes is amazing to watch, Gecko says it's the data and the software they provide that's the actual service. The robots are simply the vehicle to fetch it for them. Gecko had its origins about 10 years ago. Troy and his co-founder, CEO Jake met in college north of Pittsburgh. They formed Gecko in 2013. In 2018, they had their Series A round of funding. One of the investors was Mark Cuban, the Dallas Mavericks owner. Having lived in DFW and seen that man in action at basketball games, I had to ask about him during the interview. I was particularly curious about what it was like to go into business with the guy, like my guest has done. Anyone who's seen Entourage knows what I'm talking about.
What if I just bought your company? It's not for sale.
Yes, it is.
Go to hell.
Hey.
I'll call you Turtle.
It sounds like that may indeed be a fictional portrayal. I hope you enjoy my conversation with Troy Demmer. We're here with Troy Demmer, co-founder and COO of Gecko Robotics. And Troy, these robots of yours are pretty exciting. What kind of data are you able to capture from them?
Thanks, Jay. It's great to be here. The types of data that the robots collect, quite a few different sensors are used. Those types of data include things like ultrasonic measurements. That's actually a sound that pings the surface of the material, and that actually enables us to detect a variety of defects or failure modes that exist in something like a metal or some other kind of alloy or material. We also collect many other different types of pieces of what they call non-destructive testing data, and that could be visual inspection, magnetic induction, on down the line. We also collect things like positional data so that we know where on the most critical infrastructure that we are inspecting and trying to determine where a potential failure mode is. We have to know not just what we're looking for, but where we actually are on that asset. And so we fuse those types of pieces of data together, and that ultimately enables the customer to have a full picture and x-ray through to their assets to understand what exactly we're looking at.
And so all I've seen in the videos is this robot climbing essentially flat structures. How is this robot that I would assume is somewhat heavy and is also tethered to the ground attaching to these flat surfaces and then climbing them?
Yeah, great question. We use rare earth magnets, and most of the materials that we inspect have some sort of ferromagnetic component to it. It's a very convenient climbing mechanism. It actually enables us to climb on all sorts of geometries, vertical, upside down, really enables us to get to a wide variety of assets and geometries through that climbing mechanism.
And how are folks gathering this data before Gecko came along?
Yeah, it's something where probably over the last 60 to 70 years, this field of study emerged, non-destructive testing. And how it's always been done is using humans, right, to go and perform an inspection with a variety of different devices or meters to physically get contact with the surface and use a handheld device to gather a reading. And that process today still exists in much of the industry. And it's obviously got susceptible to many different things, but one, it's just not very scalable. Not to mention the safety concerns and things like accuracy. It is just a very slow and tedious process to go and gather single point measurements like that.
What kind of things are you testing? I assume smokestacks, towers. What have you scaled with these robots?
Today, we have about 150 customers in 4 end markets: power generation space, things like boilers, tanks, underground piping, things that are really susceptible to failure. If that failure happens, the plant has to come down, or environmental, things that could leach out into the ground or into the air.
Yeah. And Troy, you mentioned the thing about the business as usual is typically a human is, I would assume, either rappelling down something or going into a very tight, confined space. A lot of that requires permitting and probably would take a lot more time than the time it takes for you guys to maybe be able to do it, right? You're saving on time and hopefully on some permitting issues, yeah?
Absolutely. As you said, I mean, a lot of these assets, they were not built to be easily accessible. They're either containing something underground or in a confined space, as you said, where just to gain access to that is quite an extensive process, right? Because the things that's containing can be dangerous or not meant to be out in the open environment, to the whole permitting and safety process, right? It's there for a reason because these are not meant to be inhabitable. Rappelling is a great visual. That's oftentimes how they perform work today, off of ropes or very tall scaffolding. Not only is that pretty difficult and cumbersome to work off of, can you imagine swinging on a rope a couple hundred feet off the ground or climbing that many stories of scaffolding? It's a challenging task. Not only are the tools limited by single point readings, you're also working in these environments that just really aren't that conducive to be spending a lot of time in or to be working off of. We will gather on the order of magnitude of about 10,000 readings a second. If you compare that to maybe a reading per minute or every couple minutes, you can really start to cover some significant ground and make sure that nothing's missed.
Yeah, usually these kinds of inspections are done during planned outages at facilities. Are you able to, or have your clients said that they were able to reduce the amount of downtime that they had usually scheduled for these planned outages because you didn't have a person physically doing this?
Yes, that's exactly right. And there's actually 2 ways that we primarily reduce downtime. One is the greater efficiency that our robots have while they're down. And so we can get through an inspection and turn around those results much more quickly than conventional methods. But the other interesting way in which we've been able to reduce downtime is we can perform a lot of these inspections while the asset's still online. Eliminating the need to take it offline in the first place enables that asset to run longer, right? And not have that same amount of downtime. Now, in some instances, we can't do that, but there are a lot of instances where the way to inspect was to open it up, go inside, look around, pull out your different testing devices. And because of the things that we can climb and scale and read through these materials with our different sensors, it enables us to do that without ever taking things offline. So that's a major value add to the customers we serve.
Are they having to inspect as much? It sounds to me like you're able to get more granular with the data you're able to collect. You know, a lot of times they do these inspections because a lot could change, but if they have better data, would they be able to maybe have fewer inspections to begin with?
That's exactly right. And it's one of those probabilities that every organization has to accept, right? If they could, they would inspect everything every day, right? And you probably wouldn't have any failures. But that's not cost effective. And a lot of times not necessarily needed, right? If you can do a comprehensive, thorough inspection and really target and then kind of keep a watch on certain areas that are prone to damage or shown early signs of damage, then you can do something like monitoring. Gecko is in the business of providing our customers with these monitoring services that happen at pretty defined intervals, but we look for ways to both extend those intervals and in some instances move to a continuous monitoring system.
I think some people would say drones could do that. How is it better to physically attach to the equipment like you're doing?
One of the things that's important to think about is the damage that is occurring is often not seen. It's either on the inside, the interior of that piece of equipment. Hence, they used to oftentimes want to open that piece of equipment up and go inside and get an assessment of what's going on. But that, again, is very costly and dangerous and time consuming. So this is not something that can be seen visually, right? External. And even more than that, there are instances and lots of times where the damage is actually occurring in the middle of the piece of material, right? Of the steel tank. That's something that if you had access on either side, you're not going to see. So you actually have to have contact to the surface so that you can put some sort of electromagnetic frequency into it or some sort of sound wave into it, and then gather all those signals back and see the different deflections and reflections that are occurring so that you can really pinpoint if there's something occurring there, like a crack or a blister or some sort of damage in the middle of that asset that could never be seen visually without maybe doing a cross section of the asset. And that would be considered destructive testing. That's the last resort.
Yeah, I've done destructive testing for UL before, so I know that you usually don't want to waste those very much. Hey, Troy, the technology is cool, but utilities and oil and gas vendors are a little set in their ways. And I've talked about this on the podcast before. And you've mentioned that there's still a prevailing status quo with people. How were you able to get with the clients you already have to take a chance on you? Because this is high stakes. You know, this is very expensive infrastructure. There's a lot that rides on it. If it's down, the whole facility is down. There's a lot of risk involved.
This is something that really strikes a lot of people because we're a young company in spaces that, for a lot of good reasons, stick to the status quo for all the reasons you cited: risk, liability, maybe improper incentives to really try to gain a better perspective or value. A lot of times these services are seen as cost centers and not truly value add to the organizations. We've taken a very aggressive approach on communicating to outcomes and higher value outcomes that can be achieved by utilizing technology and good process that enables things to be able to gather better data insights and achieve a better outcome. We've structured it in a way that it's pretty objective, right? It's very hard dollar, things like hard dollar cost savings, things like very clear paths to value add in terms of maybe increased revenues or decreased downtime. And we've made a solution that works for both the plant and the corporate type of sponsor. And so it really becomes a compelling value both to the individual that has to maintain this equipment, oftentimes doesn't have all the solutions that they would want. And it's a very manageable way to bring into a new technology because we packaged it as a service and we made it very easy for them to obtain that service. And then the insights and the value that's being generated from that becomes viral when people throughout the organization realize how impactful this data can be outside of just we completed our inspection. And oftentimes that's what our customers are after: complete the inspection.
Yeah. Troy, I usually ask this question at the very beginning. How did you and your partners find your way to this? And what is unique about the technology? It's not just all off-the-shelf parts that you've cobbled together, right? There is unique IP here.
We definitely started with a problem in mind. My partner, Jake, and I both met at Grove City College about 10 years ago. We actually first came across this problem because a local power plant operator came to the school and said, hey, we have this boiler and we have a bunch of other equipment that we inspect and I have to use humans to do it. And I've often thought there's a better way, and is there something that you could think about? Probably a wall climbing robot would be a pretty good solution, right? So that sort of was the impetus for the idea. Over the next several years, R&D happened in a very customer focused way, right? That customer was a partner, other customers became a partner, and we had to get access to their environments. We had to understand the challenges of climbing in industrial environments, dirty environments, hazardous environments, environments, heights and confined spaces. This wasn't something we could have built in a lab. It had to be built in partnership with our customer. So that was the approach we took. And that enabled some very fast development cycles that were very focused on the customer pain points. We've personally felt the pain of what wasn't working. We operated our own robots. We provided data as a service. At the end of the day, the robots were the mean to the data. We knew what was working and what wasn't working. And we weren't going to be okay with things that made that job harder, but created a very fast iterative cycle. And all of our technology is very much proprietary. Of course, we use off-the-shelf components like cameras, but everything about that robot, the software, is patented, is protected, and is something that's taken a long time to perfect, to be able to get it to be as versatile and adaptable as it is, to integrate as many sensors as it does.
And so what's next for you guys? Inspecting wind turbine blades, maybe geothermal, any other sectors other than maybe steam generation?
One of the end markets that we serve is our power generation and our utility partners. And they have a range of assets now creating power, right? We have applications in the biomass space, hydro. We are looking at wind turbines as well, both towers and blades and the turbine component. What's really unique about Gecko is we serve customers in a way where we like to go very deep and understand how we can continue to add value across the value chain. We think about assets and how does this go from one asset to the next asset. But what we're really thinking about is how do we drive greater predictability? How do we drive greater uptime? How do we drive greater safety at that facility level? So it really becomes sort of a natural evolution of what we go and do next. And it's not just hardware. There's a lot of software that enables that as well.
So Troy, one of the things I wanted to talk to you about was some of your investors. And you got Series A funding in 2018, and I couldn't help but notice, but one of those investors was Mark Cuban, Dallas Mavericks owner. Tell us how that one came about.
Yeah, absolutely. And for those of you that don't know, Mark's actually a Pittsburgh native, so he grew up in the South Hills, Mount Lebanon area. And funny enough, first time I actually met Mark was just a casual run-in in downtown Pittsburgh in the cultural district, and that even predated Gecko Robotics. So I'm sure that had nothing to do with getting the financing. But during our Series A, we reached out to Mark, and he really loved the business we were building, having that Pittsburgh connection. And he's been an investor ever since. So he's invested in all of our latest rounds. He makes some really sound investments and has a great portfolio of other entrepreneurs that we learn from. And there's quite a network on that side. So we really appreciate all of his support. And yeah.
You sound like you're about my age. Did you ever see the episode of Entourage that he was on?
I missed that. I don't recall an episode that he's on, but I'll have to go back and watch it now.
Yeah, I assume he's got a lot of other investments and everything. But one thing I will tell you is that he does seem very engaged. I one time was at a Dallas Mavericks basketball game. We had great seats near the floor, and I was pretty much on his level. And the way he conducted the game was crazy. Like, he would stand up and twirl his finger, and things would come on over the PA. So have you had any direct involvement with him?
Yeah, and you're right. He is very engaged. I think he's just a great multitasker. I can't imagine how busy he is. Yes, he does. I mean, he responds to so many emails, updates, and personally reaches out and talks and asks questions. And he really is engaged. He really does care.
Troy, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Great. And it powers a lot of homes, heating. It's certainly a major source of power generation today, but there's also futures that don't require burning as much methane and carbon dioxide. So we'd love to see continued transition into cleaner fuel sources.
Crude oil.
Yeah, my car uses crude oil after it goes through a refining process. That's some nasty stuff. What it actually takes to produce a gallon of gasoline at a refinery is a pretty intense process.
Nuclear.
Probably one of the most misunderstood energy sources. It seems very powerful. It's one in which is highly radioactive and dangerous. So I think that probably plays into the misunderstanding of it, but it's a very sustainable energy source.
Coal, and coal with carbon capture.
Yeah, carbon sequestration is interesting. There's a power plant right down here in Maryland, and they capture the CO2 off of their process of burning coal in their thermal boiler, and they actually make CO2 for Coca-Cola.
Wind.
I've seen wind turbines increase in such magnitude and scale, going from like 1 megawatt to tens of megawatts offshore. I think offshore wind is going to be an interesting and very quickly growing sector. It will be great for the coastal cities.
Solar.
Solar is great for the middle of the country where offshore wind's not possible and it's very warm. Texas and Arizona, where the sun always shines. That's where I want my solar.
Biofuels.
I know some interesting companies harnessing biofuels. It seems like a less efficient way to power traditional fuel burning mechanisms, but it could see some synthetics being produced in the future that could be interesting. But today it feels like it's more costly to produce a gallon of biofuel, or more kind of unnecessary.
Hydroelectric.
I often think about all the dams that exist out there. Yeah, it's an interesting, in a way, clean energy source, but I also worry what it does to the streams themselves. I personally like water a lot and fishing. And when you have a giant dam in the middle of a river, it really messes with that ecosphere.
Geothermal.
I think there's some interesting things where you can do some energy storage with geothermal even. It seems like it could be an interesting way to store renewable energy that's generated during the day.
Energy storage.
This will be the key to unlocking a decarbonization future.
Electric vehicles.
I don't own one yet, but I'm looking forward to it. Probably go with a Tesla Cybertruck.
Sure. Energy efficiency.
We can all do our part to be more energy efficient. I personally like to keep my house cool in the winters and warm in the summers. Maybe I'm just frugal and cheap, but there's ways to be energy efficient.
And then finally, fusion power.
Yes, the sister to nuclear fission. Also seems very interesting and potentially much more powerful than nuclear fission.
All right. Troy Demmer, Gecko Robotics, thank you so much for your time.
Thank you, Jay. It was great being here.
And that was Troy Demmer, co-founder and CEO of Gecko Robotics, an industrial automation company based in Pittsburgh. This being an energy podcast, we really only focused on the energy sector Gecko works in. The other is pulp and paper. Troy says they are also working with the Department of Defense. I want to thank Troy for his time, as well as Dresden Leitner at Net Positive Agency for setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 123. Be sure to join us next week when we learn how one company is changing the conversation about hydroelectric. Until then, I'm Jay Downhauer. We'll see you next time.